I will try to be brief with the presentation, but I guess as yesterday when we had the spread foundation on clay, I think this will also cause some discussion. And I will also say it's the same issue as yesterday, that when you get the benchmark back, we can clearly see that from us preparing the slide, preparing the information on these benchmark, we were not clear enough on everything. And I take that back with myself, realizing that for another set of benchmarking, we have to be much, much more clear and strict on everything and what we expect to get back from the people. Because then it will be much easier to actually make the comparisons. So don't take it like we are saying that somebody have done anything wrong, because it can easily be ourselves that has not been clear enough. So, and that's your question there, actually, Jose, because we will see that we have differences here as well. But I will not spend much time on presenting the case, because Witold has already done that. So that's because as Jose say, design a strict footing. And then it was not so clear that it was the over-design factor that were the issue here to compare. But looking at the, I just skipped these ones. You know, at no water table, there is the material properties, no relevant individual discontinuities, and equivalent continuous medium. So let's see what were the result. These were the result as Witold showed from TDB2, and they do it all the 5 different equations here. And here are all the results. And actually, if those that didn't provide an over-design factor, I calculated it based on what I could find in the information back. So we actually have 3 different versions from Portugal. We have the TDB2, we have Slovakia, and we have UK presenting these results. So, and already here we can see there is different ways of actually doing the approach. You can see that Slovakia has quite a high over-design factor, and when we try to look into their calculation, they are comparing maximum contact stress and ultimate bearing capacity, with partial factor only on action and no reduction of the contact area. So they're doing a little bit differently from the rest of the group, so that's why they end up with a higher over-design value. They are neglecting some of the thoughts. UK, Portugal, and B2 made calculation with all 5 different combinations, comparing the design normal action with the design bearing resistance. But still, you can see there are at least some differences between UK, Portugal, and TDB2. So they didn't do exactly the same assumptions. So looking at the effective area of footing, because that's actually one of the things that I realize now, that we need to get a common understanding on how to do this as well. It seems to be a basic from our geotechnical engineers, but still I think we have to be clear on it. UK determined the eccentricity using characteristic actions. B2 determined the eccentricity using design values of actions. Portugal determined the eccentricity using design values of action. In addition, there is a consideration of geometrical uncertainty, reducing the B with this delta B 0.1. And that's why we see differences. You have UK, characteristic value, design values, and then in addition to the design values, we also have to reduce it with 0.1 due to geometrical uncertainty. As Witold say, when we don't have explicitly said that we actually will control it during the execution, we have to reduce it with delta B as well. And I couldn't see it in all of the examples, especially not in the UK. So that's a difference. That's one of the reasons for the differences. Another one, the normal action. B2 in Portugal add the weight of the foundation itself to the characteristic actions. Hence, they had 1100 kilonewton instead of 1000 kilonewton. But that is not done by the UK. And that's also important to think. coming back to, we have to think about the geotechnical problem we have. Of course, there is a weight of the foundation itself. So is it really relevant to neglect it? For VC3, only variable actions are factored, as Vittel has shown previously. In VC3, it's only the variable actions that are factored. But UK, by mistake, I'm not know, added the KF factors to the action factors. Hence, there is a small difference between the countries. So instead of just actually doing the material factor approach, having the material factors on the material side, they also added the KF factor on the actions.
Mistake.
Hopefully it's a mistake, I say, but I guess this comes back to me, as I said yesterday, this very nice table in Eurocode 0 is very nice when you have had the time to sit down and really understand it. But until then, it's a mess, sorry. And we really have to assist our fellow engineers in our countries to help them understand it, because it's not obvious. And I guess maybe we also need some discussions there to really make sure that we are calibrated and understand it the same way, because I'm not sure sometimes when I look at this, because this is actually one of my questions here in the end. This final column on VC4, are we really clear in our head for all different types of structures that we are designing what we mean with effect of actions and how to put the partial factor on it? Because I could see, I mean, these examples are not so much detailed, but I could feel that there is a little bit of a, actually, or are we actually adding the same partial factors in VC4 on the actions anyway, considering them as the effect of actions for this spread foundation? But actually, we should put the value partial factor on the effect of the action. So what is the effect of action when we talk about spread foundation? Is it clear for us how to use this VC4? That's one of my questions after doing this comparison here. So, and then we come to this one. This is also very interesting. Of course, MFA, bearing resistance, you have the B will, MFA, the B version would be 1.4 times km. The C version is 1 times 4 km. And A and B would be just 1.0. So there will be a relationship between these. But the most interesting one is that we have 3 different ways from Portugal here, as we already discussed here. You can put it, the partial factor on the unconfined compression strength directly. You could put it on the shear envelope, or you can get it into the more column C and phi and put the partial factor on. Which one is the correct one? And which one is the most? We have to be, I mean, this is just a benchmark example, but still we have to have the clear guidance on how to do this for the engineers. Which one is the most relevant for the specific case we are looking at? I was a little bit surprised to see 3 different ones, and I thought, okay, yeah, of course, you can do it like the 3 ones, yeah. So how would the engineer know which one to do? Coming back to being the engineer and using your engineering judgments, I guess. You come back there again. But this shows also something about how the necessity for us to be clear in our guidance for the rock engineering community on how to do this. And that's up for you in the rock engineering platform, I guess, to be giving guidance on what is the appropriate way here. But for even a simple thing like a spread foundation on rock, without major discontinuities, this is the case. And then finally, bearing resistance, if you're looking at the resistance factor approaches, it seems like if you look at the TGB2, and the UK, the yellow and the blue final column there, it seems like UK did not use the partial factor on resistance on their values compared to the other ones here. So it seems like we made a mistake there as well. Once again, coming back to, we have to understand the tables. Conclusion. It's crucial that we get a common interpretation of the different verification cases, common understanding of how to apply the consequence factors, that you cannot add consequence factors on all parameters, because then we're taking into account the consequences multiple times. Application of factors on actions or effect of actions, that's another crucial thing. It's essential to agree on how to include geometrical uncertainties. It might be crucial if the weight of the foundation is neglected. I would say it is crucial if we neglect that one. So that's my conclusion. So questions, comments on this? It's too few things coming back on this example to actually make any more detailed conclusion on it. But we might come back on that one.
Thank you, Gunilla.